Welcome to The Explainer. You know the drill. We're all told to use strong passwords, don't click on weird links, all that stuff to stay safe online. But what about the huge systems we rely on every day? Our banks, our jobs. How do they defend themselves? Well, it's kind of like building a giant digital fortress. And it all starts with a surprisingly tough question. Just think about that for a second. The real challenge isn't just about keeping the bad guys out. It's about working from the assumption that a threat could come from anywhere, maybe even from inside your own walls. This one idea has completely changed the game in how we think about cybersecurity. And this isn't just some abstract theory. It plays out every single day in the real world. Take this question from a new firewall manager on Reddit. They're trying to figure out the best way to set up their rules, and they're facing this classic trade-off. Do you make the rules super specific and complicated, or do you keep them simple and broad? That question, it gets right to the heart of the whole challenge. Okay, let's dive in. So let's start with the most basic part of any fortress, right? The big wall around the outside. In the digital world, that first, most famous line of defense is, of course, the firewall. Now, a modern firewall isn't just a simple gate. Oh no, it's more like a super high-tech security checkpoint at the border. It's got the guards, the scanners, the passport control, all rolled into one. It inspects every bit of traffic trying to come in or go out, and it makes a call based on a very strict rulebook. And this is exactly the dilemma our Reddit user was talking about. On one side, you can write a separate, specific rule for every little thing. That gives you amazing control, and it lets you follow what's called the principle of least privilege, which just means you only grant the absolute minimum access needed. But man, it can get messy fast. On the other side, you could just make one simple rule that covers a bunch of stuff. It's way cleaner, but you might be giving more access than you really should. It is the constant battle between perfect security and practical simplicity. But here's the thing. A big wall is great, but it's not enough. You also need really smart guards watching the gates, looking for anything that seems off, even if someone has the right key. And that is the job of something called an Intrusion Detection and Prevention System, or IDPS. This is your network's elite security detail. It's always watching, always analyzing the traffic that the firewall lets through, looking for suspicious behavior. So how does it actually spot a threat? Well, it's got a few clever tricks up its sleeve. First up, the system is kind of like a guard with a huge book of wanted posters. It has a massive library of signatures. Think of them as digital fingerprints for all the known viruses and cyber attacks. If any piece of data comes through that matches one of those fingerprints, busted. It gets stopped right there. This is awesome for catching the threats we already know about. But what about the new threats? The attacks that nobody has a wanted poster for yet? For those, the system acts more like a veteran guard who's been on the job for 20 years and just has a gut feeling when something's not right. It spends time learning what normal looks like on the network, and then it flags anything that deviates from that pattern. A sudden flood of data at 3 a.m.? A computer trying to talk to a server it never talks to? That's weird. Flag it. And then there's the most advanced method. Think of this guard as a language expert. They don't just look at faces. They understand the grammar of how different applications are supposed to talk to each other. If a request is structured in a weird way, or a command is sent out of sequence, the system knows the grammar is wrong and immediately flags it as a possible attack, even if it's a completely new type of threat. It's pretty brilliant. Okay, so we've got our strong outer wall, we've got our super smart guards, but what if a really clever attacker, a digital Trojan horse, still manages to sneak inside? This is where the whole idea of a simple castle with one big wall starts to completely fall apart. The second an attacker gets inside, the game changes entirely. The goal isn't prevention anymore. Now it's all about containment. You have to limit the blast radius. How do you stop that one intruder from running around the entire castle and getting to the crown jewels? The answer is something called network segmentation. You build walls inside the fortress. Instead of having one giant open-plan network, you chop it up into smaller, isolated zones with locked doors between them. That way, if an attacker gets into, say, the main user network, they can't just wander over to the data center where all the sensitive stuff is stored. A fire in one room doesn't burn down the whole house. And the way this works is really cool. First, you classify everything on the network, every user, every laptop, every server, and you give it a tag, kind of like a digital name badge. And here's the important part. That tag is based on who or what you are, not where you are physically located. Then, that tag follows you everywhere you go across the network. Finally, the network itself enforces the rules based on these tags. So a user with a sales team badge simply isn't allowed to open the door to a server with an engineering R&D badge. End of story. So you see how all these layers, the firewall, the smart guards, the internal walls, are all critical pieces of this puzzle. But they all point toward a single unifying idea, a core philosophy that really governs all of modern security. And we are right back to that first question we asked. What happens if you just decide you can't trust anything by default? This is the revolutionary concept that totally flips traditional security on its head. The whole idea can be boiled down to this one simple mantra: never trust, always verify. This is the absolute core principle of a framework we call zero trust architecture. What zero trust does is it completely tears down that old idea of a trusted inside network and an untrusted outside world. I mean, think about it. With remote work, cloud applications, and all our different devices, there is no inside anymore. The perimeter is gone. Zero trust just assumes that every single request to access something is a potential threat, and it has to be verified. Every user, every device, every single time. No exceptions. So let's put it all together. When we assemble all of these pieces, what does our modern digital fortress actually look like? Let's do a quick recap. We start with our firewall, that's layer 1, the big perimeter wall. Then we have our IDPS, that's layer 2, our vigilant guards at the gate. Then we have network segmentation, layer 3, which builds all the internal walls and locked doors to contain any breaches. And then, at the very core of it all, we have the zero trust philosophy. Never trust, always verify. It's the law of the land that governs every single interaction. And really, that's the single biggest takeaway here. This is a strategy called defense in depth. Security isn't about building one giant, perfect wall anymore. It's about moving away from that single checkpoint at the edge and instead weaving security into the very fabric of the entire network. And it's all based on who you are, not where you are. This all leaves us with one final, pretty mind-bending thought to chew on. As our digital world becomes more and more connected, more borderless, that old idea of a fortress perimeter is just dissolving. It really makes you wonder, in a world where everything is connected to everything else, where does security even begin anymore? And where does it end? That's a question we're all going to have to answer together. Thanks for joining us on The Explainer.